Hello friends, today I will discuss a new topic and this is line, surface and volume integrals, and I have divided the whole video into three parts. So line integral will be covered in part A, surface integral will be in part B and volume integral will be in part C. Now basically line integral mainly deals with single variable, surface integral mainly deals with double variable and volume integral mainly deals with triple variable. Now if there are more than three variables, then you can just write it as multiple integral. Obviously for greater than equal to 2 you can just call any integral into a multiple integral. Now before start the part A, that is line integral, I will discuss few things. First one is, you can say integration is an inverse of differentiation. That means suppose d dx of fx equal to gx, then dfx equal to gx dx. Now if you take integration into both sides, then you will get the integration and differentiation will get cancelled, so you will get integration gx dx equal to fx. Now there is another thing which I would like to discuss, that is d dx of, if you take fx plus c, c is any arbitrary constant, then you will also get the same result and ultimately you will have gx dx equal to fx plus c. So usually we use an arbitrary constant c whenever we are just computing an integral. Obviously the integral should be indefinite integral. And another point is, say point 2, suppose you have a definite integral a to b fx dx. It means you are just integrating this f function from a range a to b. Suppose you are just considering this is fx, so this area is also considered as the integration between a to b, and this is obviously a definite integral. Next point I would like to discuss is integrability or integrable. When you can just integrate a function, there are several theories on that. If I loosely speaking about that, usually a continuous function or a class of continuous functions are integrable. But there are some points we have to just remember, that every continuous function you cannot integrate into a closed form. Suppose if you are trying to integrate e to the power x dx, this is a continuous function, so you can easily integrate that function. But e to the power x square dx, this is also a continuous function, but the indefinite integral is not possible here, so we need to also think about that difficulties. The function is integrable, but we are not able to do the integration, so indefinite integral is not possible. So we are just considering a small class of functions here, and obviously if there are some kind of definite integral, say a to b to the power x square dx, the limits are, you know the limits, suppose say 2 to 3 e to the power x square dx, you can also integrate that one, but there are some numerical methods available, so using that you can solve it. Further, it is also note that some discontinuous functions are also integrable. Say for example a function box x dx, so say minus 2 to 2, this function is discontinuous but it is also integrable. Usually the functions with jump discontinuities may be integrable, and sometimes if a function is having finite number of discontinuities, then this function also integrable. So that was the basic ideas which I wanted to discuss. Now we will move to the problems. I will start with very basic integration, which is x to the power n when n is not equal to 1, and this integration x to the power n dx equal to x power n plus 1 by n plus 1 plus c. Here n not equal to minus 1, otherwise there will be a problem. Second part, if n equal to minus 1, then this integration reduced to 1 by x, and this is equal to ln x. Now remember, log x and ln x are different. In log x, we are usually considering base 10, and ln x, we are considering base e. And in calculus, we are deal with ln x. E power mx, this integration will be e power. Obviously, all integration will having an arbitrary constant c. So e power mx by m plus c. Next is a to the power mx. So a to the power mx dx will be a to the power mx by ln a plus c. Then integration sin mx will be minus cos mx by m plus c. Again, integration cos mx dx will be sin mx by m plus c, and last one will be sin square mx. So this type of integral, either sin square or cos square, what you have to do is you just multiply it by half and 2 sin square mx dx, and you can just write it as integration 1 minus cos 2 mx dx, and here you can just write it as integration dx minus integration cos 2 mx dx. So half x minus sin 2 mx by 12 plus c. In a similar way, you can just solve any other type of trigonometric functions, and this type of formula we are just achieve through only differentiation. Say, for example, you are just trying to do 1 by dx equal to ln x plus c. Now, if you differentiate ln x, then you will have 1 by x. So, from differentiation, you can directly achieve those formulas. Next, integration cos x, we already discussed that. Cos square x, we also discussed that. Tan mx, you can just write this sin mx by cos mx, and just substitute cos mx equal to z. You can easily integrate that one. For sec square mx, and this is tan mx by m plus c. Sec into tan, and this is sec mx by m plus c. Now integration of cosec square x, this is minus cot mx by m plus c, and for the last one, this is minus cosec mx by m plus c. In the next part, I will discuss this type of integration. So, if there is a constant, then constant can go outside, and you can write it as c into fx dx. Here, integration will be distributed to both of the functions. So, integration fx dx plus minus integration gx dx. Now, this rule is actually integration by parts, and you can write it as integration uv dx equal to u integration v dx minus integration du dx integration v dx then dx. And here actually one function is integrable and another function is differentiable. So you can just decide which one will be integrable or which one will be differentiable. Now, to prove this, we will just use d dx of uv. This is the rule of differentiation. So, u dv dx plus v du dx. Here, if we put dv dx equal to z, that is dv equal to z dx or v equal to integration z dx, then we get duv equal to u z plus du dx integration z dx into dx. Now if we integrate both sides, we get uv equal to integration uz dx plus integration du dx integration z dx dx. So let me clear the board first. Well, so integration uz dx equal to u, so just putting this into that side, uv means, so u integration z dx minus integration du dx integration z dx dx. Now just z is a dummy variable here, so you just replace z into v, then you can have the result. Now we will discuss the integration root over x square minus a square dx. Here we will use the integrating by parts rule. Here we will just differentiate that one. So here we just consider this 1. So root x square minus a square integration dx minus integration, so d dx root x square minus a square into integration dx dx. So here x root x square minus a square minus integration, and this differentiation will be 2x by 2 root x square minus a square. This is a standard differentiation, and x here dx. So x root x square minus a square minus integration x square by root x square minus a square dx, and you can write it as x root x square minus a square minus x square minus a square plus a square by root x square minus a square dx. Here just see x square minus a square minus integration root over x square minus a square dx, and we will denote it as I. This minus, if you take a square comma, then dx by root x square minus a square, and here this will go to the left side. So 2y equal to x root x square minus a square minus a square integration dx by x square minus a square. Here for this integration you can just put x equal to a sec theta, then dx equal to a sec theta tan theta d theta, and you will get x root x square minus a square minus a square integration a sec theta tan theta d theta, and in the denominator you will get a tan theta, so tan theta a will get cancelled, and you will get x root x square minus a square minus a square log sec theta minus tan theta and plus c. Looking at the board, now 2i equal to x root x square minus a square minus a square log, so what is our sec theta? Sec theta is x by a minus what is our tan theta? So tan theta will be root over x square by a square minus 1, that is root over x square minus a square by a, root over x square minus a square by a plus c, and you will get x root x square minus a square minus a square ln x minus root x square minus a square plus some constant, this will be c1, and for I you just divided this by 2, so x by 2 and this by 2, and again this constant will be some kind of c1 rest. So this is done. Now using similar method you can also solve that problem. Okay, so next, this integral, and this integral we have already solved. So here you can just easily put x equal to a sec theta. For this one you can put x equal to a tan theta, and you can easily solve this integral. For this you can put x equal to a sec theta. Let's see. So here I equal to, if you put, okay, just write down this one, x square minus a square. Just put x equal to a sec theta. So dx equal to a sec theta tan theta d theta. Now you will get integration a sec theta tan theta d theta and a square tan square theta. And 1 tan theta will get cancelled. So 1 by a integration sec theta, that means 1 by cos theta, and here tan theta, that means sin theta by cos theta d theta. So 1 by a integration cosec theta d theta, and this will be 1 by a ln cosec theta minus cot theta. Now you just replace this theta in terms of x, you will have your answer. Now for this one you can put x equal to a tan theta and just proceed accordingly. Now for this one we will use integration by parts. So integration ln x dx, you can just write it as 1 into ln x dx equal to, so we will just differentiate that one and we will integrate this one. So just x ln x minus integration, so this one, this integration of 1 will be x and differentiation of ln x will be 1 by x. So dx, and ultimately you will get x ln x minus x plus c. Now for this one you can just use x plus 1 equal to z and proceed similar to the previous one. Next, log x. So log x means it has base 10. So log x dx, we can just write it as integration ln x by ln 10 dx. So 1 by ln 10 integration ln x dx, and this is similar to that one. Now tan inverse x or any kind of inverse function, say for integration tan inverse x dx, we will use again integration by parts. So 1 into tan inverse x dx, so we will integrate that one and we will differentiate that one, that tan inverse x. So x tan inverse x minus integration x and differentiation of that one, so 1 by 1 plus x square into dx. Now x tan inverse x minus integration, so x by 1 plus x square, so I will just add 2x by 1 plus x square dx, and you can write x tan inverse x minus half ln mod 1 plus x square plus c. Now similarly you can integrate any kind of inverse function, so integration sin inverse x or cos inverse x, you will just proceed according to tan inverse x. So you can easily solve that one. Now we will discuss some special type of integration. Here as you can see, the numerator has 1 and denominator has 3 factors, x minus 1 into x minus 2 into x minus 3. So here it has, the denominator has degree 3 and numerator is a constant. In that case we will use partial fraction. Here we will start with, see, x minus 1 into x minus 2 into x minus 3. You can write it as a by x minus 1 plus b by x minus 2 plus c by x minus 3. Now just multiply both sides by x minus 1 into x minus 2 into x minus 3. So you will get 1 equal to you will get x minus 2 into x minus 3 into a, plus here x minus 2 will get cancelled, so you will have x minus 1 into x minus 3b plus x minus 1 into x minus 2 c. Now put x equal to 1, then you can get, if you put x equal to 1, then this part is 0, this part is 0, so 1 equal to minus 1 into minus 2 into a. That means you will have a equal to 1 by 2. Again, if you put x equal to 2, then let's see what happens. Okay, so 1 equal to, so this part and this part will get cancelled, so only b part will be there. So 1 into minus 1 into b, that means b equal to minus 1. And if you put x equal to 3 here, then a and b part will be 0, and only you will have the c part, so 1 will be 1 equal to 3 means 2 into 1 into c, so c equal to 1 by 2. So the value is a equal to half, b equal to minus 1, c equal to 1 by 2. So let me just clear the board, and you will have 1 by 2 into 1 by x minus 1 minus 1 by x minus 2 plus 1 by 2 into 1 by x minus 3. And now if you integrate both sides, then you will have integration dx by x minus 1 into x minus 2 into x minus 3 equal to integration dx integration dx integration dx, and you will have 1 by 2 ln mod x minus 1 minus ln mod x minus 2 plus 1 by 2 ln mod x minus 3 plus c. So for the second problem, we will again use the partial fraction. Now here we need to check the numerator has degree 2 and denominator has degree 3. So denominator is greater than numerator, that means we can use partial fraction, and we will just again write it down, x square by x minus 1 into x minus 2 into x minus 3 equal to a by x minus 1 plus b by x minus 2 plus c by x minus 3. And again the same process, we will just multiply x minus 1, x minus 2, x minus 3 to the both side. So x square equal to x minus 2 into x minus 3 into a plus x minus 1 into x minus 3 into b plus x minus 1 into x minus 2 into c. And again we will put x equal to 1 and 2 and 3 to get the values of a, b and c, and then we can integrate this easily. Now for the next one, here it is x power 4 by x minus 1 into x minus 2 into x minus 3. Here as you can see, then numerator has degree 4 and the denominator has degree 3. So in that case we can just write x power 4 x minus 1 into x minus 2 into x minus 3, and here only 1 degree, so 4 minus 3, that means 1. 1 means you can just write ax plus b plus c by x minus 1 plus d by x minus 2 plus e by x minus 3. Now if this deficit is say 2, then you can just change this as ax square plus bx plus c and so on. For your information, I have just wrote this one. Again I will just multiply this, x power 4 equal to ax plus b into x minus 1 into x minus 2 into x minus 3 plus c into x minus 2 into x minus 3 plus d into x minus 1 into x minus 3 plus e into x minus 1 into x minus 2. Now if you put x equal to 1, 2, 3, then you can get the values of c, d and e. Now how to get this a and b? So there are 1, 2, 3, so 1, 2, 3, 4, 5 constants are there. So to find the values of a and b, we can just compare the coefficient of x power 4 So in the left hand side, coefficient of x to the power 4 equal to 1, and in the right hand side, these 3 will be x cube and this will be x to the power 4. So in right hand side, coefficient of x to the power 4 is a. So obviously a equal to 1. Now you also have c, b, e values and a values. Now lastly, what you can do, you just put x equal to 0. Now if you put x equal to 0, then left hand side is your 0. Okay, just let me use another color. So left hand side is 0 equal to this part. Okay, so this part will be b into minus 1 into minus 2 into minus 3 plus c into minus 2 into minus 3 plus d into minus 1 into minus 3 plus e into minus 1 into minus 2. Now you have the values of c, b and e. You can easily find the value of b here, and you can just easily integrate that one. Now for the last one, integration. Okay, I'm not writing this because it's already written here. So here the numerator is degree 4 and denominator also has degree 4. So here you can just write x power 4 x minus 1 into x minus 2 square is there and x minus 3. You can just write it as a plus, because 4 minus 4 equal to 0, so 4 minus 4 equal to 0, that means a constant will be there. So a plus b by x minus 1 plus here square is there, so c by x minus 2 plus b by x minus 2 square plus e by x minus 3. And you can just use the previous type of idea and you can easily find the values of a, b, c, d and e. And another one I would like to discuss is, say, dx by x cube plus 1. And here you can just write it as dx x plus 1 into x square minus x plus 1. Now this part, so x plus 1 into x square minus x plus 1, this has degree 1 and this has degree 2. You can write a by x plus 1 plus bx plus c by x square minus x plus 1, and you can just use the previous argument to find the values of a, b and c. Basically the idea is to multiply both sides with that part, so x minus 1 into x square, that x square minus x plus 1, and you can just have the values of a, b, c. Sometimes you need to put x equal to 0, or sometimes you need to check the coefficients of the x, that means check the coefficients, or sometimes you need to check the constants, and like that. Sometimes you can put the values of x also, and these are basically called identities. These are basically called identities. Okay, now for this problem you can just use, this is basically x square plus 1. We need to differentiate that one, so 2x. You can write this as 2x dx plus integration 3 dx by x square plus 1. Now this can be easily solved by putting x square plus 1 equal to z, and you will get, so just if you differentiate that x square plus 1, then you will have 2x. So this is ln x square plus 1 plus 3. We already did this integration. So this is tan inverse x plus c. So you can easily solve that. Next, x power 6 by x square plus 1, integration x power 6 by x square plus 1. Now what you can do, you can just divide this x square plus 1 and here x to the power 6. If you divide this, there will be x to the power 4. So x to the power 6 plus x to the power 4, so minus minus. Now minus x to the power 4 will be there, so minus x square, so minus x power 4 minus x square, so plus plus and x square. So here we can use 1, x square plus 1 and minus 1. So minus 1 will be remainder. So you can have this equal to x power 4 minus x square plus 1 minus 1 by x square plus 1. You can just divide easily. This is your x power 5 by 5 minus x cube by 3 plus x minus tan inverse x plus c. For the third problem, we will just try to adjust this part. So dx, first we will take common 1 by 2 and we will have x square plus 3 by 2x plus 1 by 2 equal to 1 by 2 integration dx x plus 3 by 4 whole square. Because if you whole square that one, then you will get x square plus 2 into 3 by 4, that means 3 by 2x plus half will be there minus 9 by 16. And if you put x plus 3 by 4 equal to z, then you can get, so let's check this one. So dz, here dx equal to dz, so dz by z square, and this will be 16, 8 minus 9 minus 1 by 16. So that means 1 by 2 integration dz by z square minus 1 by 4 square, and this is standard form. You can easily integrate that one. And similarly for the second one, you can have just one root there, and this is also a standard form, so you can easily solve that integration. For the next integral, you can just try to differentiate the denominator, and okay, just I will write down the denominator. So 2x square plus 3x plus 1, the differentiation of that will be 4x plus 3. Now 4x, we need a 4x, so 1 by 4, 4x plus 4, because of that, so 4x plus 4. Okay, sorry, we are just doing that one. It doesn't matter actually. 4x plus 4, so 4x plus 3 plus 1 dx, and you can just write 1 by 4 integration 4x plus 3 by 2x square plus 3x plus 1 dx plus 1 by 4 integration dx by 2x square plus 3x plus 1. The second part is that one which we just already discussed, and this one will be ln mod 2x square plus 3x plus 1. And similarly we can solve this problem also. For the next problem, that is this one, we will just use 2x plus 3 equal to z square. The form is actually dx by ax plus b root cx plus d, and you can just put cx plus d equal to z square. So for this is the general form. Now we will just solve that one. 2x plus 3 equal to z square. So dx equal to z dz. Now here from, so I equal to that, for I equal to dx equal to z dz, and denominator will be x plus 1. So x will be your z square minus 3 by 2 plus 1, and ultimately you will get z square minus 1 by 2. So z square minus 1 by 2 into z, and this is a standard form. So 2 integration dz by z square minus 1. You can easily solve that one. These integrations are basically some special type of integrations. Here you can just put x plus 1 equal to 1 by z. The idea is, so in the general form actually is dx by ax plus b square root of cx square plus dx plus c. So all this form you can just generalize all these forms. So let's back to that problem. X plus 1 equal to z. Now dx will be minus 1 by z square dz. So just write it as I. So I equal to minus integration dz by z square into x plus 1 equal to 1 by z. So 1 by z into root over, you can just write x equal to 1 by z minus 1, and you can just write 1 minus z by z, and just put the values of x here, 2 into 1 minus z square by z square plus 3 into 1 minus z by z plus 1, and 1 z will get cancelled from here, and again another z square will be coming out, so all this cancelled. So minus integration dz by root 2 into 1 minus z whole square plus 3z into 1 minus z plus z square. Now you can easily just solve this, because it looks like a form dz by root over az square plus bz plus c. You can just solve this by some kind of integration dz by root over z plus alpha whole square plus minus some beta square, and all this form are known form. Now for the second problem, so let's limit it by I. We will put 3x square plus 4 equal to x square z square. From here we can get 6x dx equal to 2x z square dx plus 2z x square dz. Now just write down the 2x dx into that side. Now we can get 2x into 3 minus z square dx equal to 2z x square dz. 2 will get cancelled, 1x also get cancelled, so we have dx equal to xz by 3 minus z square dz. In dx we have, now this is our zx, xz, 2x square plus 3, we even need 2x square plus 3, so from here we can get x square 3 minus z square equal to minus 4, or x square equal to 4 by z square minus 3. We need 2x square plus 3, so 2x square plus 3 will be 8 by z square minus 3 plus 3, and we have z square minus 1 by z square minus 3. Therefore I equal to integration 1 by 2x square plus 3 will be z square minus 1 by z square minus 3 into, this is our xz, and dx will be xz by 3 minus z square dt. Xz will get cancelled, 3 minus z square and z square minus 3 will get cancelled, so ultimately there will be dz by 1 minus z square, and we can easily solve this one. For the third one, let's take this equal to I equal to integration dx by 2 into x square plus 3 by 2x plus, I need to write it as a whole square form, so 3 by 2, 9 by 16, because 3 by 4 whole square, so 2 into 3 by 4, that means 3 by 2, and 2x square plus 3x will be there, and the other term will be plus 1 minus 9 by 8 power 3 by 2. Now integration dx by 2 into x plus 3 by 2 whole square plus, no, plus minus 1 by 8 power 3 by 2. Now x plus 3 by 2 equal to z, and dx will be equal to dz. This is dz, and we will have 2z square minus 1 by 8 power 3 by 2. That means integration dz into 2z square minus 1 by 8 into root over 2z square minus 1 by 8. And again, this is like the second one, and you can just put 2z square minus 1 by 8 equal to some z into w, and just proceed as usual. And for the fourth one, this is also a special type of integration, so x minus a into b minus x dx. Here we will put x equal to a sin square theta plus b cos square theta. Dx will be 2 a sin theta cos theta minus 2b sin theta cos theta. And if you just obviously a d theta will be there, and a minus b, 2 into a minus b into sin theta cos theta d theta. And now what about x minus a? So x minus a will be b cos square theta. If you take minus a common, so minus a into 1 minus sin square theta, so b minus a cos square theta. And again, what about b minus x? So b minus x will be sin square theta. From here you can get, if you just square root, then we have b minus a and sin theta cos theta, and again for dx, 2 into a minus b sin theta cos theta, 2 minus 2 into a minus b whole square integration sin square theta d theta. A minus b whole square minus will be there, so 2 sin square theta, that means 1 plus cos 4 theta d theta, and you can just integrate this easily. And after the integration, if there are some kind of sin theta or cos theta, then you can just replace the values from here or here. Now another type of integration is that one. So dx by a sin x plus b cos x plus c. Just multiply I. So I equal to, just write this as 2a sin x by 2 cos x by 2 plus b into cos square x by 2 minus sin square x by 2 plus c into this 1, so sin square x by 2 plus cos square x by 2 dx. And just then divide this by cos square x by 2, so we will get sec square x by 2 dx by, so just I will collect all these coefficients, so c minus b into tan square x by 2 plus 2a tan x by 2 plus b plus c. Now put tan x by 2 equal to z, and when you put tan x by 2 equal to z, then sec square x by 2 dx, and there will be a half, so this will be dz, and ultimately, okay, just let me solve one more line. So sec square x by 2 dx equal to dz, we can get 2 integration dz by c minus b z square plus 2az plus b plus c. And this type of integration we already covered. And for the second problem, this is also similar, the root there, so this type of integration also we covered. Now we will discuss that integration. So there will be 4 sine functions in multiplication form. So I equal to integration sin x, sin 2x, sin 3x into sin 4x dx. Now we will take 2 functions and then use the formula. So the formula, just recall the formula: 2 sin alpha sin beta equal to cos alpha minus beta minus cos alpha plus beta. So just multiply this by half integration. So cos x minus cos 3x into, okay, again these two you can also multiply, so 1 by 4, and this is cos x minus cos 7x dx, and 1 by 4 integration cos x square minus cos x cos 7x minus cos x cos 3x plus cos 3x cos 7x dx. There will be another formula which is 2 cos alpha cos beta equal to cos alpha plus beta plus cos alpha minus beta. Now using this formula we can easily solve the integration. Next we will discuss some various type of integrals. So first one is 1 by sin square x dx. So you can write it as cos x square x dx, and this we already know. This is minus cot x plus c. Again for sin cube x, integration sin cube x dx, you can just write it as sin x into sin square x dx in integration sin x into 1 minus cos square x dx. Now put cos x equal to z, then you have minus sin x dx equal to dz, and you can easily solve that problem. In a similar way, you can also solve cos cube x. Now sin power 4x dx, you can just write half or say 1 by 4 into 2 sin square x then whole square dx. Now you can write it as 1 by 4 integration 1 minus cos 2x whole square dx and 1 by 4 into 1 minus 2 cos 2x plus cos square 2x dx. This part is easily integrable, and for this part you can again write this as half into 2 cos square 2x, and you can again write it as half into 1 plus cos 4x. You can easily integrate that part. In a similar way, you can also find integration cos power 4x dx. Now let's move to the next problem. This is integration cos ln x dx. So I equal to this. Now put ln x equal to z, that means x equal to e to the power z, dx equal to e to the power z dz, and you will have e to the power z into cos z dz. Now use integration by parts. So we will integrate that one and differentiate that one, that cos z. We will get e to the power z into cos z minus integration e to the power z cos z differentiation minus sin z, so there will be plus dz. Again e to the power z cos z plus, again we will differentiate that one, that sin z, e to the power z sin z minus integration e to the power z cos z dz. Now e to the power z cos z, this is our I, so this is equal to I, so we have 2I equal to e to the power z into sin z plus cos z. It implies I equal to e to the power z by 2 sin z plus cos z. In a similar way, you can also find sin ln x. And we will solve the last problem, which is integration ln cos x dx. Now we will just use integration by parts. So x ln cos x minus integration x, differentiation of ln cos x will be sin x by cos x, there will be a minus sign, so plus this dx, and x ln cos x plus integration x tan x dx. Now we will not able to solve this indefinite integral, but if instead of this indefinite integral, if it is 0 to pi by 2 ln cos x dx, that means a definite integral is there, then we can solve this. So I will just proceed 2 or 3 lines. Let's see. So I equal to 0 to pi by 2 ln cos pi by 2 minus x, so ln sin x dx. Now if we add these two, then we will have 2y equal to 0 to pi by 2 ln sin x cos x dx. Now you can just write this as 0 to pi by 2 ln sine 2x by 2 dx, and 0 to pi by 2 ln sine 2x dx minus 0 to pi by 2 ln 2 dx. Now what you can do, this is you can easily solve. So this is pi by 2 ln 2, and for this part you can just put 2x equal to z, and ultimately you will find this part is equal to some I, or some something into I, some ci. C may be 1 or not, maybe 1. I don't know. I need to check it out. So like this you can solve that one. Next we will discuss some special type of definite integral, and it involves mod function. So before going to solve this problem, first we will recall the definition of mod function. So mod x equal to x if x greater than 0, or mod x equal to minus x if x less than 0. Now for the first one, minus 1 to 2 mod x dx, we have minus 1 to 0. So this is negative part. So minus 1 to 0 mod x equal to minus x dx plus 0 to 2 mod x equal to x, because this limit is greater than 0. So mod x equal to x dx, and you have ultimately minus x square by 2 minus 1 to 0 plus x square by 2 0 to 2, and we have minus 0 minus half plus 4 by 2 minus 0. Ultimately we will have 5 by 2. Now for the second one, integration minus 1 to 0 x into mod x equal to minus x dx plus 0 to 2 x into mod x equal to x dx. Now this is an easy integration, so we can easily solve that one. What about minus 1 to 2 mod x plus 1 dx? If x is say minus 0.5, then this is so. In that range, mod x plus 1 is always positive. So minus 1 to 2, this is x plus 1 dx. And you can easily integrate that one. Next is minus 1 to 2 mod x minus 1 into x minus 2 dx. Here you just think about the function. So x minus 1 into x minus 2, and the range is minus 1 to 2. Now if what you can do, you just divide the range. So minus 1, 0, 1, 2. This is the simplest form. So from minus 1 to 0, say minus 0.5, you are just taking one value, and you can easily check that. So this is minus, this is again minus, so this is positive. Again, if you take 0.5 here, so x equal to 0.5, that means this is negative, again this is negative, so ultimately this is positive. And if x is greater than 1, then this is negative. So what happens, this function is positive in minus 1 to 1, so this is, you can write x minus 1 into x minus 2 dx, and negative in 1 to 2, you can just write x minus 1 into x minus 2 dx. So you can just integrate as usual. Now 0 to pi sine mod x, 0 to pi sine mod x dx. Now this is simple, because mod x you already know, this is x if x greater than 0, and this is minus x if x less than 0. So in that range, this you can just simply write 0 to pi sine x dx. Now I would like to discuss, if instead of sine mod x it was 0 to pi mod sine x, then what will happen? In 0 to pi by 2, the sine function is positive. Again, pi by 2 to pi, the sine is also positive. So this is also 0 to pi sine x dx. Now instead of that, if this is 0 to 2 pi sine x dx, then 0 to pi sin x dx minus pi to 2 pi sin x dx, because from pi to 2 pi sin x is negative. So this is basically the mod functions, how to integrate mod functions. And if instead of sin there is a cos, if okay, just let me discuss 0 to 2 pi mod cos x dx. So 0 to pi by 2 cos x minus pi by 2 to 3 pi by 2 cos x dx plus 3 pi by 2 to 2 pi cos x dx. The next part involves box function, and before going to solve the integration, first we will just recall what is a box function. So box x usually denotes the greatest integer less than equal to x. Greatest integer less than equal to x. That means box 1.2 equal to 1, box 1.9 equal to 1, box 1.5 equal to 1. Again, from the negative side, minus 0.5 equal to minus 1, minus 1.5 equal to minus 2, minus 1.9 equal to minus 2, and like this. So box x, if we just write down this function, then for 0 less than x, 0 less than equal to x less than 1, this is 0, 1 less than equal to x less than 2, this is 1, 2 less than equal to x less than 3 equal to 2, and so on. And here, okay, so minus 1 less than equal to x less than 0 equal to minus 1, minus 2 less than equal to x less than minus 1 is minus 2, and so on. Now if we solve this first one, say minus 3 to 3 box x dx, then we will just use the definition. So minus 3 to minus 2, it has the value minus 3 dx plus minus 2 to minus 1, it has the value minus 2 plus minus 1 to 0, it has value minus 1 plus 0 to 1. Just follow this function. 0 to 1, it has value 0, plus 1 to 2, it has value 1, plus 2 to 3, it has value 2. Now you can just easily integrate that one, and you will have your result. Now all these integrals we will discuss here into basically two forms. So form 1 will be integration function of box x dx, or form 2 box of function x dx. This one is very easy, because once you just split the range of box x, then you are done. But for this one, box of function x, you need to find out the range for the function. So let's see how to do this. This is form 1, and this is also form 1. Here what? Minus 3 to minus 3, so minus 3 to minus 2, the value is minus 3, so minus 3 square dx, we are just using the function again, plus minus 2 to minus 1, value is minus 2, so minus 2 square dx, and so on, that problem. And for minus 2 to 2 e to the power box x, this is also similar. So what you can do here, minus 2 to minus 1, the value is minus 2, so e to the power minus 2 dx, plus minus 1 to 0, the value is minus 1, so e to the power minus 1 dx, and so on. Now this one is form 2, this one is form 2, and I will discuss that one also. Minus 3 to 3 box x square dx. Here you need to see when this box x square function changes its values. So let's see box x square. See, if you take the value, say minus 1 less than x less than 1, then you will find x square is less than 1. So box x square is equal to 0. So here this is equal to 0. Now let's think 1 less than equal to x less than root 2. Then what about x square? X square is 1 less than equal to x square less than 2. So up to 1 to 2 the value will be 1. So this is 1. And again root 2 less than equal to x less than root 3, the value will be 2. And here minus root 2 less than x less than equal to minus 1, the value will be 1, because if you just square this part, then you will have your answer. Again, for minus root 3 less than x less than equal to minus root 2, the value will be 2. And here, just instead of minus 3, you can just write minus 2 to 2 box x square dx, because you will automatically understand how this minus 3 to 3 will work. Divide the range. So here minus 2 to minus root 3, the value will be 3 dx, plus minus root 3 to minus root 2, the value will be 2 dx, plus just follow that x square. So minus root 2 to minus 1, this will be 1 dx. Then minus 1 to 1, this is 0, plus 1 to root 2, this is 1 dx, plus root 2 to root 3, this is 2 dx, and root 3 to 2, this is 3 dx. Now I think I have just made it clear. So by using the same argument, we can easily solve minus 3 to 3. So there will be some more extra terms, you can easily solve that one. Next is minus 3 to 3 box x plus 1 dx. Now we need to construct that function x plus 1. Now if x has the range 0 to 1, 0 less than equal to x less than 1, so x plus 1 will be 1 less than equal to x less than 2. So this is 1. Now if minus 1 less than equal to x less than 0, this is 0. If minus 2 less than equal to x less than minus 1, this is minus 1. Minus 3 less than equal to x less than equal to x less than minus 2, then this is minus 2. And similarly for the positive side, if we take 1 less than equal to x less than 2, then this is 2, and 2 less than equal to x less than 3, then this is 3. Now we can easily solve that integration. So minus 3 to minus 2, minus 2 dx, plus minus 2 to minus 1, minus 1 dx, and so on. So we can easily solve that one also. Now the next one is minus 3 to 3 mod x into box x dx. Now what you can do, just so minus 3 to 0, mod x is minus x, so minus x into box x dx, plus 0 to 3 x into box x dx. Now you can just integrate, means use the box function from 0 to 3 and 0 to minus 3. So you can solve that one also. for this kind of functions, so we just recall that one form is integration box of fx, this one is difficult, and another one is integration f of box x dx, this one is easy. So let's identify, this is say form 1 and this is say form 2. Now form 2 and this is form 2, this is form 1, this is form 1. These two we will just solve after solving this form 2. So for that one, 1 2 3 ln box x dx. Now here we will just directly use the box x formula. So here 1 2 2 box x equal to 1, so ln 1 dx plus 2 2 3 ln 2 dx. Now ln 1 is 0, ultimately we will get 2 2 3 ln 2 dx, ln 2, and this integration value will be 1, so this is ln 2. Next one is that one, so 0 to pi by 2 sine box x dx. Now box x, okay, 0 to pi by 2, that means 3.14 by 2, this is our pi by 2, 1 point something, here 0 to 1 sine 0 dx plus 1 to pi by 2 sine 1 dx. So it will be sine 1 into pi by 2 minus 1. This is the answer. Now it's time to solve form 1. So the first one is integration 1 to 3 box ln x dx. Now let's see the ln function. See, ln x, this function is equal to, ln 1 is 0, so 1 less than equal to x less than e, then this function is 0. So ln e equal to 1, so less than e, ultimately the box function is 0. And for e, the value of e is approximately 2.71, and that means e less than equal to x less than 3. This ln value will be 1 point something, so ultimately this is 1, and we will get 1 to e 0 dx plus e to 3 dx, and ultimately we will get 3 minus e. The next problem is 0 to pi by 2 box sin x dx. Now from 0 to pi by 2, the value of sin x is 1, or basically less than equal to 1. So from 0 to pi by 2, box sin x will be 0, 0 less than equal to x less than pi by 2, and ultimately this value will be 0. Now I will discuss a specific type of integration problem which involves some kind of inequalities. So here, as you can see, we have given an integration and we need to check whether this integration lies between any of these limits. Here, as you can see, we have already discussed the integral dx by root over a square minus x square, but this integration is somehow different. So that is why we need to use some kind of inequality. So let's see. Here the integration range, that means the range of x is 0 to 1, and in 0 less than equal to x less than equal to 1, or say 0 less than x less than 1, x square is greater than x cube. As we already know that, say for example, if you take half, then half square greater than half cube, and like this. Now minus x square less than minus x cube, and from here 8 minus x square minus x cube. So 8 minus x square, we are just adding both sides. 8 minus x square minus x square less than this. And again, if you put x equal to 0 here, then this part is less than 8 minus x square. Here x equal to 0 if you put. Now just take square root on all this side. Now you are just reciprocal to that. So whenever we are just doing reciprocal, then inequality sign will change, or you can just write root 8 minus x square less than 1 by root 8 minus x square minus x cube less than 1 by root 8 minus 2x square. Now integrating, okay, so we will get this. This inequality can be like this, and okay, just let me clear the board first. You can just write it as dx by root 8 minus x square less than equal to p less than equal to integration dx by root 8 minus 2x square. Now this and this integration are easy to solve, so we can have our result. So for this part we can just take 2 common, and easily the form is dx by root a square minus x square, and we have already solved that integration. We will discuss integration in form of limits. Basically this is the definition of definite integral, and it says integration a to b f x dx equal to in a limit form. So this limit form I will try to explain here. So here a to b, we are trying to integrate a function say fx. Now what we are trying to do here we are just dividing the whole range into some subintervals, and these all have h, length h, so a plus h, a plus 2h, and so on. Last point is b, and ultimately a plus nh equal to b, that means nh equal to b minus f, as you can see here. Now the idea is here, see, we will just draw some vertical lines. Now we will just try to find out this area. Now this is h, and this is actually fa. Similarly, this is our a plus h. This is f of a plus h, and so on. Basically, what about this area? This area is h into fa. Then the next area will be h into f of a plus h. So h into fa plus f of a plus h plus dot dot dot, like this. And as you can see, this is the form. And one more thing, what I would like to say, the h tends to 0. That means, see, okay, if you have a curve, and here the error is this, for say this is h. Now instead of this h, if you take h here, so just take here, so this is and this, so now the error is low. That means as h is getting smaller, the summation value tends to that integral. That's the idea behind this definition. And after that, if a equal to 0 and b equal to 1, then we can easily write down this integral in a standard form, and using that form we will solve some problems. So basically 0 to 1 fx dx equal to limit h tends to 0, h summation r equal to 1 to n f of rh, where nh equal to 1. This is the idea. Here our target is to limit n tends to infinite 1 by n summation f of r by n, this summation is varying on over r, equal to limit h tends to 0, h summation f of rh, and this is 0 to 1 fx dx. This is our target, and let's see how we are just achieve this function. So here first limit n tends to infinity, 1 by n is needed, so 1 by n and like this, and now we are just dividing this by n square, and ultimately we are getting this function alpha. So limit n tends to infinity, this. Now if you put 1 by n equal to h, then ultimately we will get this function, and rh equal to x, so you will have 0 to 1 x by 1 plus x square dx, and this is a simple integration. Now for problem number 1, let's see. This is limit n tends to infinity. Now we will take 1 by n common, so 1 square n by n cube plus 1 cube plus 2 square n by n cube plus 2 cube plus dot 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 n square into n by n cube plus n cube. You can just write limit n tends to infinity summation r equal to 1 to n r square n by n cube plus r cube equal to limit n tends to infinity 1 by n summation, just we are dividing this and this by n cube, and we will get r square by n square by 1 plus r cube by n cube, and if we put 1 by n equal to h, then limit h tends to 0, h summation r square h square by 1 plus r cube h cube equal to integration 0 to 1 x square by 1 plus x cube dx, and just write it as 3x square 1 by 3, then 1 by 3 ln 1 plus x cube 0 to 1, and we will get ln 2. Next problem is also similar. Let's see. Limit n tends to infinity 1 by n summation r equal to 1 to n by root minus r square will be there, because 1 square 2 square it's going like this, so n 2r into n. The pattern is like this, so if r equal to 1 then 2, if r equal to 2 then 4, and like this. So just limit n tends to infinity 1 by n summation r equal to 1 to n 1 by root over, just dividing in with numerator and denominator, so we'll have 2r by n minus r square by n square, and limit h tends to 0, h summation r equal to 1 to n 1 by root over 2rh minus r square h square. So we will have 0 to 1 dx by root over 2x minus x square, and we can easily solve that integration. For problem number 3, it is also similar. Here we will take L equal to these limits. So ln L equal to limit n tends to infinity 2 by n square ln 1 plus 1 by n square plus 4 by n square ln 1 plus 2 square by n square plus 2n by n square ln 1 plus n square by n square. Now you can write limit n tends to infinity summation r equal to 1 to n 2n 2r by n square ln 1 plus r square by n square. Now if you put r equal to 1, then you will get first term. If you put r equal to 2, then you will get second term, and like this. Now just take 1 by n common, so r by n. Now this is limit h tends to 0, so h equal to 1 by n here. This is h summation 2 rh ln 1 plus r square h square, and ultimately you will get 0 to 1 2x ln 1 plus x square dx. Now you can easily solve that integration by putting 1 plus x square equal to z. Problem number 4, limit n tends to infinity 1 by n summation r equal to 1 to n square root n plus r by n. And if you put 1 by n equal to h, so limit h tends to 0, h summation root under 1 plus rh, and ultimately you will get 0 to 1 root 1 plus x dx. Now the next and last topic of this video is differentiation under integration, and here we will use Leibniz integral rule, and this rule basically, as you can see, so this differentiation with respect to x, and here if x is a function of x and t, then the limit is constant, integration limit, then the formula is like this, and the formula number 2 and 3 is basically Leibniz integral rule. So I can just give one example for that. Now suppose, for example, if you want to calculate t dx, now the limit is constant, so suppose 2 to 3, and f of xt, we are just taking a function, so x square t cube dt, then this will be your 2 to 3 del x, so del x of this will be 2x t cube dt, and now you can easily integrate with respect to t, and like this. Next is the second formula. Here the limit is variable, so let us take d dx, say x to e power x square t cube dt equal to f of x dx, here so x square into e power 3x into ddx of dx is e power x minus f of x into ax, so x square x cube into ddx of x, 1 plus integration x to e power x, and if we partially differentiate, so this term 2x into t cube dt, and for the last one t dx, say x to e power x ft, only function of t, so t cube dt, then according to that formula it's e power 3x into e power x minus x cube into 1. So here we have taken, for the third one we have taken ft equal to t cube, and for the first and second one we have taken f of xt equal to x square into t cube. Now according to Leibniz formula, you can easily find, say gx equal to x square ft dt, then according to formula 3 g dash x equal to f of x square into d dx of x square minus f of x into d dx of x, and ultimately we will get 2x f x square minus fx. It can be easily established. There is an integration of ft. Suppose we are taking integration ft dt equal to some function phi t. Now from here you can get phi dash t equal to ft. Therefore gx equal to x to x square ft dt equal to, now the integration of ft is phi t, so phi t x to x square, so phi x square minus phi x, therefore g dash x equal to phi dash x square into 2x minus phi dash x. Again phi dash x square will be from there, phi dash x square equal to f of x square, and phi dash x is also fx. So just 2x f of x square minus f of x. That's the formula. Now example 1.9 is a direct application of formula 3. Here we will just take ft equal to root 4 plus t square. So therefore fx equal to x cube to 4 ft dt. Now f dash x equal to f4 into d dx of 4 minus f of x cube into d dx of x cube. So this part is 0 and ultimately we will get minus, so f of x cube will be root over 4 plus x power 6 by root over 4 plus x power 6 into 3x square. Now f dash 1, so put x equal to 1, we will have f dash 1 equal to root over 5 into 3 equal to minus 3 root 5. So answer is A. Example 1.10 also direct application of formula 3. So here f dash x equal to fx into d dx of x minus 0. So I am not going to write that. This is fx and fx will be x cube from here into 1 plus 1 by 5 cos ln, so 4 ln t. Now you just double derivative to that, so f double dash x equal to 3x square into 1 plus 1 by 5 cos 4 ln, so this is not t, this is x, 4 ln x plus x cube into minus 1 by 5 sine 4 ln x into 4 by x. Now this x will get cancelled and this will be x square. F double dash 0 will be 0. For example 1.11, here we will first differentiate that one. So we have fx into 1 minus 0 equal to 2x sine x plus x square cos x plus 3x square. So therefore f of pi by 2 equal to cos pi by 2 0, and we will get sine pi by 2 1, 2 into pi by 2 plus 3 into pi by 2 square, so pi by 2, and we will get 2 plus 3 pi by 2. For the problem number 1.12, we can easily solve that one because f dash x equal to fx and f double dash x we can find, this is f dash x. Now f dash x can be found from here and put x equal to 0, then you will get f double dash 0. So this is very similar to the previous problem. For problem number 1.13, we need to find the number of roots, and here we need one idea. So a function fx is increasing if f dash x greater than 0 and decreasing if f dash x less than 0. Now for capital Fx, we need to find f dash x equal to e to the power x into t square, into x square minus 3x minus 5. So this is the direct application of rule number 3, and the given interval is 0 to 4. So f dash 0 is minus 5 and f dash 4 is minus 1. F dash x within the interval, so f dash x in 0 to 4 is less than 0. That means fx is decreasing in 0 to 4. Now what about fx? Fx at 0 is 0. As you can see, the limit is 0 to 0, so this is 0 and it's decreasing. So it looks like the function, this is x-axis and this is y-axis, and f0 0, and now it's a decreasing function, so it looks like this. So there is no way to cut this blue graph to the x-axis, so the number of root is 0. In this context, I would like to add that if a function has a root, that means x equal to 0, so it has to cut the x-axis. So suppose this is a function, say, okay, just let me color it. This is a function and it cuts 2 points to the x-axis. That means at 2 points the function has x equal to 0. Sorry, y equal to 0. That means fx equal to 0. This point fx equal to 0, again this point fx equal to 0. That means this function has 2 roots. But in our function, there is no possibility within 0 to 4 such that the function just cross the x-axis. So that is why the number of roots is 0. Now 1.14 is a combination of L'Hospital and the differentiation under integration rule. So let's see how we solve this problem. Here, if x tends to half, then denominator is 0 and the numerator is also 0. So this is a 0 by 0 form. So we will differentiate this. So limit x tends to half and the denominator will be e to the power 2x into 2 by 2. This will get cancelled. So 2x into e, and the numerator will be cos square pi x. This is the direct application of rule number 3. Again, if you put x equal to half, this is a 0 by 0 form. Again, we will just differentiate that one by L'Hospital rule. So x tends to half, 2 e power 2x minus 2 e, and this is the numerator will be 2 cos pi x into minus sin pi x into pi. This is again 0 by 0 form. So here you just let me write this. So limit x tends to half. First I will just write this 2 sin x, okay, so minus pi sine 2 pi x by 2, so pi by 2 will be in the outside, e power 2x minus e. Now this is again 0 by 0 form. This is minus pi by 2, limit x tends to half, and 2 pi cos 2 pi x by 2 e power 2x. Now if we put the value of x here, so we will get minus pi by 2 into these 2 will get cancelled, so pi into cos pi, so this is minus 1, and e, and this minus will get cancelled, so ultimately the result will be pi square by 2e. This is the answer. Now 1.15, this is also a combination of L'Hospital and differentiation under integration sign. So this function is 0 by 0 form. Now using L'Hospital rule, get limit x tends to 0, 2x into 3x square into f x cube minus 2x into f x square. This is the direct application of rule 3. Now as x tends to 0, you can write limit x tends to 0, 3x f x cube minus 2f x square by 2, and here we will get limit x tends to 0, so half will get outside, and 3x into f x cube. Here x tends to 0, that means x not equal to 0, so we will use tan t by t. Here tan cube x by x cube minus 2 tan square x by x square, and this part is 0 as there is a x multiplying with this term, and here minus limit x tends to 0, tan square x by x square, and this is sin x by x, so this is 1, and cos x cos 0 1, ultimately we will get, so this term actually equal to 1, and we will get minus 1 as limit x tends to 0, sin x by x equal to 1. So tan x can be written as sin x by x into 1 by cos x. There is a whole square, so it doesn't matter. This is 1, this is also 1, the whole part will be 1, and the answer is minus 1. Now the last problem in this topic is 1.2, and this problem is basically complicated, and I will try to solve this step by step. First, hx is given. This is a 2 variable function, and we need to find h dash 1. So the first step is hx equal to, it is given 0 to x f of uv du du. Now first integration f of uv du equal to some phi function. So this integration we are taking it as some phi uv. That means integration f uv du equal to phi uv. Therefore this is 0 to x some phi uv, here u equal to 0 to x, and then dv, and ultimately we will get 0 to x phi x v minus phi 0 v dv. Now hx equal to 0 to x phi xv dv minus 0 to x phi 0 v dv, and here we will use formula number 2, and here this is basically 2 variable, we will use formula number 2, and here we will use formula number 3. Now we come to formula 2 and formula 3. So h dash x will be, this is formula 3. If we use formula 3, then what we will get? We will get, so here a equal to 0 and b equal to x, and instead of t there is b, so it doesn't matter. This part will be phi 0 x, and this differentiation will be 1, and this part will be 0. And for the second part we have here a equal to 0, that part will get cancelled, phi x and x, and ddx of this is 1, so phi xx minus 0 plus 0 to x, and this is del x of phi x v dv, and we will have h dash x is phi xx plus 0 to x del x phi xv dv minus phi 0x. So we have found h dash x. Now go to the problem. Again, so we have the expression of h dash x, and again from this assumption we have del phi del u equal to f of uv. So this is phi xx plus 0 to x f of xv dv minus phi of 0x. Therefore h dash 1 according to the question is phi 11 minus phi 01, so x equal to 1 here. This now phi 11 minus phi 01, this can be written as 0 to 1 if v1 dv, because integration if v1 dv is phi v1, and 0 to 1 will be this 0 to 1. So obviously v equal to 0 to 1. So if you put the phi 11 minus phi 01, so we get this, and the second part is already achieved. So ultimately the result is 0 to 1 f of 1 t plus t1 dt. So this t is some kind of dummy variable. So the answer T is correct. Thank you.